Welcome to the Manitoba Ag Days podcast, where we hear from some of the most relevant, up-to-date, informational speakers in our industry. In episode 5, Jarrett Chambers, President, ATP Nutrition, shares his story, pushing the crop's genetic potential, agronomic practices to make it pay.
So when we think about things, just because of the group, I'll answer the questions myself. But when we think about putting on a herbicide or a fungicide, do we normally think to put those on to increase yield or preserve the yield potential that's been established genetically? It's about preserving and protecting. When we put on fertilizer, we're all negligent in this, in that we actually say we put on fertilizer to increase yield. Well, that's where the paradigm shift has to change. We put on balanced nutrition to actually try to preserve the genetic potential that exists. Today, we're globally at the red line. About 20% of the genetic potential of the crop. The International Plant Nutrient Institute has dated strongly, 60% of the genetic potential of the crop can be managed through proper plant nutrition. That shift is where we need to go. So to grow more crop, we can be cynical, like I'm saying in this slide. It is quite easy on paper, and it's a lifetime, it's a generational thing, it's centuries to actually get there. All we need is a good uniform stand, 100% crop canopy. We need more pods per plant, more seeds per pod, and bigger seeds. If there's no questions, we can move on, because I guess we're done, right? That's all it takes. Now the real question is, how do we get those last 3 points there? So, generally what we do in fertilizer, what we do with nutrition is something is wrong with my crop, let's go fix it. My crop is looking sick, can you come and fix it? When you see your plant looking sick, how much yield do you think you've lost? 10, 20%, 30%? Maybe that's why we're at 20% of genetic potential of the crop. Well, we can't fix that. We know that. So we think about Lieberg's law of the minimum, and I call this generation 1.0 in terms of nutrition, where we're looking at a nutrient, an element in isolation. Do we ever grow a crop in isolation of one single variable? Probably not, right? So it's a good foundation to work off, and this is a great example of this. This was some work that was published last year, great research. The sad part is it was a nitrogen study, and in this nitrogen study here in Manitoba, they were trying to grow 200 bushel corn, and they only got a nitrogen response in 55% of the trials. Only 5 out of 9 trials, the nitrogen actually worked. So how many of you people would feel comfortable to grow a 200 bushel crop and 45% of the time you wouldn't put on nitrogen? How many people would take that risk? So this is a great conversation. This is where we need to start thinking bigger than an individual element. So we need to think about being reactive. The photos here aren't very good. We need to think about, let's keep that plant ahead. How many times have you ever thought, my crop looks so good, let's push it? If you're going to try to drive production, that's what you do. My crop looks so good because I did everything right up front. I did a soil sample, put on the right rate, placed it properly, used the right seed, all the other variables. Now can we even push it more? So this is really where it comes down to the extension of Lieberg's law, which is actually Dr. Wallace's law, which is the law of the maximum, the proactive approach. The approach that all these variables are all linked together, and the net response of any given input is greater once you address them all. I'm going to use this as an example. This is a study that, if this was a nitrogen study, just the nitrogen study, and we didn't put anything else, this would look very similar to that corn trial. Nitrogen here gave us a 4 bushel response by itself. When we put on nitrogen and phosphorus, we actually got 8.5 bushels more. But did we get 8.5 bushels more due to the phosphorus? Or did we actually get 13 bushels more due to proper nitrogen and phosphorus nutrition? And then from the boron, in this piece of data, if you look at it in isolation, it says that boron gave us 10 bushels. Or does it make more sense that addressing the 3 limiting factors, nitrogen, phosphorus, and boron, gave us 23 bushels? Which one makes more sense? Which one's more logical? But look at that. The amount of nitrogen on the right never changed. But maybe we got to harness the power of nitrogen, got to harness the power of phosphorus, got to harness the power of these other elements when we address the limiting factors, not in isolation, but together. So we think about this Stay Green approach. We think about all the world record crops out there. Should a crop mature from the top down, or should the crop mature from the bottom leaves up? It's the difference between maturing and dying. Any world record crop, any high-yielding canola crop, corn crop, wheat crop, the heads always mature first. They always mature first because it's about converting sunlight into energy, moving those photostimulates into the head. So we did a trial here in Manitoba, and we decided to say, what's the importance of every leaf? Everybody says the flag leaf's the most important leaf. That was true. That is true. But do you think the other leaves are important as well? So what we actually did is we actually took off the flag leaf and left all the other leaves. Then we actually left the flag leaf and took all the other leaves, which is kind of the way maybe it was 30 years ago, 40 years ago, 50 years ago when this information was generated. Then we took all the leaves off once heading occurred. And what we saw in terms of the harvesting, the gross harvested weight in these controlled conditions, we had a 12% yield loss by removing the flag leaf. We had about a 6% yield loss removing the lower leaves but keeping the flag leaf. And we had about a 29% yield loss when we removed all the leaves. However, because we harvested everything, we got different sized kernels. Only the trays on the left are the only ones that would have stayed in the combine. The middle tray and the right-hand tray would have went out. They were too small. They never filled. So if we take that in consideration, and what we actually saw is when we removed all of the leaves, we had a 33% yield loss. 11% yield loss by losing the lower leaves and a 17% yield loss when removing the upper leaves. The key thing there, every leaf is important. Every leaf is a factory. It's about converting sunlight into energy. All nutrients are essential. They're all essential. All elements are essential. I always ask a question. It's rhetorical. It's an area that I worked on very hard for many years, trying to use SPAD meters, chlorophyll meters, trying to keep things green. And then I did a really smart thing after 4 or 5 years of being frustrated working with these tools, is I actually asked the question, what makes a plant green? What element? And what I realized, the question is not what element, it's what elements. And the answer is every one except calcium and boron. So when your plant is not perfectly green, you've only eliminated 2 elements, calcium and boron. It can still be nitrogen, sulfur, phosphorus, potassium. Sulfur, I already said that, magnesium, and your trace elements. We don't know which one it is. So we need to look at that. We need to drive this through. This is an interesting thing. I started it this way. I used to use this slide, thinking about nutrition, balanced nutrition like a car. And that each element plays a role in making that car roll forward. Photosynthesis, but to drive that, we need to target the roots. But to really target balanced nutrition, we need to take this a little step further because there is so many variables. There's so many variables that control production. This is just an example of the many variables, and today we're only talking about nutrition. But one of the things I really want to talk about and use as a reference is I've evolved as well that I thought plant nutrition, we could use a car as a representation, as a metaphor. But then when you think about it, a car is absolute. There is a muffler, there is a transmission, there is an engine, there is oil, there is fuel, tires, and so on. The problem is, what's the dietary habits of everybody in this room? Are they the same? What's our goals of everybody in this room? Some of us are just to have enough food to get to the trade show today. Some of us are to run a marathon. Some of us are to sprint. Everybody's dietary goal is different. If we think about high-performance athletes, do they eat one Tim Hortons meal a day? Or they eat a lot of meals a day? Small, regular, balanced, addressing the problems. So we got to think about this. We got to think about plant nutrition like a thoroughbred, that we're pushing this. We're pushing the crop. Very complicated, very hard to do. One of the things that we have done is we've actually made these nutrient wheels to basically say at different times in the growing season, different growth stages in the plant's life cycle, what are the essential nutrients that are key to preserving the genetic potential of the crop. Now, this is kind of a good plant physiology way to base off. Greg helped work on some of these wheels at A&L along with a number of other people. But what I want to drill in a little bit more here today is get back this genetic potential and start digging into real things. So when you start thinking about doing a trial, this becomes your biggest hypothesis that you have. This is another way to look at the half full versus half empty glass. You can see all this data. You can see one data point. You can see 1,000 data points. You don't really believe the data half the time. If somebody explains the science, you understand the science. You ask the questions about the science. You understand why did that happen? How does that happen? That's the way humans work. We still need to do it on our own farm because we got to see if it works in our situation. But the question is, if you take option one, I'm pretty sure you're not going to get a very good response. I want to see if this fertilizer works on my farm. Didn't do a soil test, didn't do a tissue test, don't have a lot of history, but I heard about it through somebody or in the coffee shop. And the chance of it working is just like Regas throwing coins in the field. Or you can actually say, let's do our research ahead of time. Let's ask why. Let's ask how. Let's understand how that nutrient that we're looking at looks. Then let's pick the field that is the most responsive to that nutrient based off a soil test. And let's set up a trial to see how I can get that nutrient to work on my farm. Half empty is option one, half full is option two. If you think about your success stories and you think about your lack of success stories, think about which question you ask yourself. And I'm pretty sure we all have the same answer in regards to that. So some of the work we did this year in Manitoba, we do a lot of work here. We had 2 main sites. We had 42 trials. One of the things we did that I thought would be interesting to show today is the fact that fertilizer works. Is anybody surprised by that? Fertilizer works, right? We're all on the same page? But actually in 4 of the 9 trials, nitrogen didn't work. So I say that cynically, right? So what we do is we actually take a site and we do what people should do. We take soil samples. How many people soil sample? All the fields, all the time, 1 every 3 years. You don't always have to do it every year, but you have to be sure that you understand your soil. Greg's going to talk about that. This is A&L's soil health test. This was our site. Greg's going to get into this later. This is a slide because of the light here, you can't see it. But our soils are not static. In fact, they're the farthest thing from static. This is A&L's data from 2009 versus 2013 for Manitoba. And unfortunately, you can't read the red. And what this is showing in the red is the top red is phosphorus, the bottom red is boron. And what it actually shows through their 20,000 soil samples that they did here in Manitoba is that the very low to low levels of phosphorus in 2009 went from 31% to 2016 to 60%. So 1 out of 3 fields was phosphorus responsive from the soil samples in 2009. 2 out of 3 fields were in 2013. Zinc, you can see that where it's sitting. Boron, you can't see because it's in red, but we've gone from 6% of the soils showing responsive to boron to 44% of the soils. And why is that? Are we putting on those nutrients, or are we just removing them? Soils aren't static. If we don't manage our soils, if we don't look at our soils as a good bank account, we get into the wrong side. We get into the red rather than the black, and the red gets us into a whole bunch of trouble. So we need a lot of nutrients to grow a crop. We know that. We've heard about this before. It's really just a setup slide. Some of the key things that we need to think about is moving past the nitrogen model. I spent 7 years working on control-release fertilizers and NBPT, and it was a super exciting time in my life. But where my paradigm shift happened was when I was only getting 5 out of 9 responses on a nitrogen trial. That wasn't my data, but I mean 5 out of 9 trials. Then you start thinking about, what about these other elements that are required? They're all essential. And of course, they all respond differently. Some crops have a higher response to certain elements versus other ones. This is just a chart that we pulled out. Some are very high responding, some are not. So we think about our site and what we did, we actually put on average fertility and high fertility on canola, and same thing on wheat. So we actually split the trials in our sites this year. Canola's at the top, this aerial view, wheat in the middle, soybeans on the bottom. And even during the season, just using canola's example, because talking about canola here today, the soil sample said we were challenged in phosphorus, we were challenged in potassium, we were challenged in sulfur, we were challenged in zinc, and we were challenged in boron as well. In these trials here, we still showed that in our tissue test, boron was really struggling. So we're going to talk about that in a minute. But when we looked at high fertility versus average fertility, we saw that in the case of canola, which is the top, it was a 21 bushel yield difference. Now, this is across 168 individual treatments that had nothing to do with the overall fertility. So the way it was replicated, the back half of every plot was replicated with a higher fertility, the front lower average fertility, and then all of the 14 experiments with the 5 to 15 treatments per experiment are all tabulated into the top number, canola at 62 versus high fertility at 83. If we graph that out from one side to the other, moving from the left side of that plot to the right side of the plot, you can see the yield variability or maybe the consistency as you go from trial 1 all the way to trial 13. Now, what's interesting is in the middle, you're going to see the lower yields here in yellow. And I put the letter F, and that was because for about 10 days there was some standing water in these plots. Due to a little bit higher rain this past year, I know it's hard to believe, but this site had a little bit of higher rain. There was some standing water. And look what it did to the yield. But the interesting piece is with the proper plant nutrition, the average response across all 14 trials was 22 bushels. But where we had stress on the plant, proper nutrition actually brought up to about 27 bushel difference. So proper nutrition created proper plant health, which helped address some of the stresses. In this case here is a lack of oxygen. And that's not a good stress to have. It's kind of a bad stress to have, as we all can relate to. But again, just a really good example of some of the things that's going on. So when we think about it, it's all about the root system. It's all about the rhizosphere. Greg's going to talk about the rhizosphere, but this is really where confusion starts. This is the doorway between soil science and plant physiology. The doorway where fertilizer goes from being fertilizer in the soil to being a nutrient in the plant. This is the key area. How many people have ever seen a sick-looking plant with a good root system? Sometimes the simplest questions are the ones that make you think. If you've ever seen a sick-looking plant with a good root system, please send me the photo. Which is why we need to be sure that we need to address our bank account, and Greg will talk about soil health. We're also going to talk about soil health. Greg's going to go into details. Hopefully your slides will show better than this, Greg. But we did some work with A&L Lab showing that, guess what? The soil microflora is affected by the fertility and the health of the plant in the soil. This is the work that we did with A&L, showing under our high fertility versus our low fertility, the fungal population and the bacterial population were different depending upon what the fertility program was. And Greg's going to get into a lot of details on this. It's very interesting stuff. So we think about some of this work. I'm going to quickly go through this, but I grabbed boron just as an example because it was a boron-responsive site. We knew it was a boron-responsive site because the soil sample said that. We knew it was a boron-responsive site because we had last year's history that showed this. We also did a tissue sample. We also showed that the plants were boron-challenged as well. Great place to actually do a boron trial. Probability of getting a boron response in a boron-deficient soil that has showed history of boron deficiency is probably a lot better than a plant has optimum boron. Would everybody agree? Sometimes it's just that simple. So when we do this work, boron, there's the challenge between deficiency and toxicity. So what we decided to do was we decided to say, can we kill the plant by putting on a whole bunch of boron in the seed row? Not a recommendation, but we just wanted to see what we could do. And there's some interesting learnings we got from it. We're just going to highlight a couple of them. This is boron toxicity. Two different forms of boron. One was a granular form, one was a liquid form. And this is actually through our scanning work with our three-dimensional scanner that we use. We saw that as we put boron into the seed row, we didn't totally kill the plants, which is unfortunate because we tried to kill them. Because you want to kill things, right? Because you want to figure out where's your threshold. We didn't quite kill them, but what we did see up to a 35% reduction in the amount of roots as we added more boron, from 1 pound to 2 pounds to 4 pounds of boron. But the interesting piece, this soil is so responsive, even with this, in terms of the yield, it was quite dramatic. As we went from 1 pound to 2 pounds to 4 pounds with the liquid, we started losing yield. But even on the one number in this site here, the yellow bar right here, this is an 11 bushel bump. Now, why is it 11 bushel bump? We put on the other nutrition. We addressed Wallace's Law. We knew the site was deficient. We targeted the site, and it looked really, really strong. Again, the granular boron, a little bit safer on the plant. We can see the rate didn't have as big a variable. And, of course, there's going to be residual benefit from some of those higher rates. So if we take some of this higher yield and we talk a little bit about our Ag in Motion plot, which in 2016 we started these. This was in Langham, Saskatchewan. It's not in Manitoba. It was a chance for us to really try to push that crop. We want to put an economics around it, but what we really wanted to do was to say, let's pick good genetics, let's pick good husbandry, let's try to do something larger than small scale, try to get it as large as we can, and highlights the benefits of trying to keep a good program, good proactive program, foliar, plus good strong soil program. So in 2017, we did it again on canola. These were the 4 treatments, a good strong fertility program on the 2 left plots, a higher fertility program on the right, and in these 2 middle plots, we then started doing supplemental applications based off tissue sampling. So we had average fertility on 2 on the left, high soil fertility 2 on the right, based off trying to target 100 bushels of canola, and the 2 in the middle was based off in-season diagnostics to figure out how we can push it. So we wanted to be sure we had proper genetics, proper fertility, supplement it, robust crop. So what we know is we always wanted to target this because the plant is always under stress. So when we thought about this, we need to deal with the stress. Plant's under stress 4 times in the year, at germination, at the start of rapid stem elongation, at flowering, at maturity. That's the only time the plant's under stress. And it's all right. I try to be cynical and try to get a rise out of you. So basically what happens, you fertilize a crop, you put a crop under stress because you're asking the plant to grow harder. It's under stress under these 4 times of the year. So we need to think about addressing these. On the seed, we put on starter fertilizer. Another thing, the rapid vegetative growth stage, that's just right after herbicide timing. Flowering, we're putting on a fungicide timing. Maybe late season application, we're doing stuff as well. These stresses are heightened, of course, by Mother Nature. So seed nutrition is something that's really critical. And seed nutrition is not new. Seed nutrition, Dr. Les Henry gave me this book, and of course you can't see any of the words, but it was actually the history of agriculture in Great Britain from 1654. And I don't know if anybody's ever heard of Dr. Francis Bacon. And what Dr. Bacon actually did in the 1600s is that they realized their seed wasn't very good. So what they actually did, and I don't think you can actually see it there, is seeds were soaked in water, suspended with dung of cows, horses, and pigeons, also of chalk and human urine and claret wine. And there was stimulation in germination. So just about 370 years ago is when they started actually realizing seeds weren't nutrient balanced. Just something to think about. Seed nutrition, very critical. We got all these expensive genetics. We're working with A&L in regards to what is the critical nutrient status of seed to drive early season vigor. This is just a quick sample of photos. We won't worry about this one. Seed nutrition is like a starter fertilizer. It's really about getting that crop out of the ground quick. Remember, we're sprinters here. We're thoroughbreds. We only have 90 days to grow a crop. We got to get it out of the ground quick. Once it gets out of the ground, it can acquire the moisture that's in the ground. And once it acquires moisture, it acquires the nutrients. Because we have to remember, plants don't go and grow the root system to find nutrients. They grow the root system to find water. And in that soil solution is the nutrients. In that water is the nutrients. So you need to think about driving roots early on. You need to think about early season nutrition to really, as we're starting to potentially get some of this yield drag on the plant. And this is where stress happens. This is where it's an opportunity to deal with herbicide hangover. It's an opportunity to give the plant a second starter fertilizer. It's to help a plant for that 7 to 10 days when maybe the temperatures aren't quite right and it's kind of a little lethargic and it's kind of sitting there. How many times have we seen our canola sitting at the 2 to 3 leaf stage? And it just sits there, and it sits there, and it sits there. Then it starts to warm up, then it takes off. And we say that's normal. That's not normal. Plant's job is to grow every second it can. Again, it's a thoroughbred. It's a racehorse. It's trying to sprint across the finish line here. This is a great chance to address things we've overlooked. Grab a tissue sample. We'll talk about that. And we want to talk about the plant, that the plant is under stress. This is just an image that doesn't show very well, showing that a plant, in this example here with Dr. Romheld's work, showing when a plant was under phosphorus stress, it actually uses a lot of energy to actually acidify the rhizosphere to acquire phosphorus. So rather than using its energy it's made through photosynthesis to grow more roots, using its energy through photosynthesis to grow more leaves, it's having to use energy to actually acidify the soil to acquire phosphorus and zinc and copper and other elements. That's negative effect. We want a positive effect. We want to be sure we're driving it. So the images doesn't show the plant is under stress. This is a great example of some work we did with Copenhagen University showing when a plant is under manganese stress. When a plant is under manganese stress, it overheats. How many times have you seen that you have potassium deficiency and the plant starts to wilt under sandy areas when it gets kind of hot during the day? It's about water regulation. Potassium is important for water regulation. In terms of manganese, similar effect. The plant starts to overheat. When it starts to overheat, it starts to get wilty. Not a very good thing to happen. So we really want to overcome some of this herbicide hangover that we see in some of these images here. And we really want to drive that crop. We want to drive it. We don't know if on the right-hand side where there was an application put on that plant is more advanced, is that's going to be positive or negative. I guess the question is, do you want your crop to look healthy or not look healthy? Do you want your crop to be lethargic or do you want your crop to grow quick? Now, if it gets all of a sudden the weather turns sideways on us, maybe the check is a better treatment. But last time I checked, I want to keep crops growing as fast as we possibly can. So there's some critical tissue work that's done that's very important. How many people tissue sample? How many people are frustrated with tissue sampling? Probably. One of the things that we look at, in this case here in some of our plots, we look under our high fertility. This is on our site in Langham, high fertility versus low fertility. And early on, we can actually see the differences in some of the elements that are already in trouble under the low fertility. And if they're already showing up in the tissues, this can be a real problem. Now, a lot of people take one tissue sample a year, and all the literature says use that tissue sample for information for the future crop. So it's basically something to put in your file to next year. Well, the ironic thing, if you do that approach, this year on that piece of land you grew canola. Next year maybe you're growing wheat. But wheat requires different nutrients and different ratios than canola, so you never really get a chance to utilize that tissue sample. So my suggestion, which maybe sounds a little negative, is that if you only do one tissue sample a year, it's a report card, probably don't even do it. But if you want to do it 2 to 4 times, and then actually start targeting lower and upper leaves. Target the plant during the different stress periods where there's a high nutrient draw, a high nutrient demand on the plant, maybe just prior to it. Old leaves versus young leaves. Nutrients are mobile on the plant. This becomes critical. We don't have time to go into this. But this is just an example of showing old leaves versus young leaves. What actually happens? The plant is not uniform. The plant at different stages, if a plant is out of balance, outside of calcium and boron, it will actually remobilize those nutrients from the old leaves to the young leaves to address some of its challenges. So we start seeing in this example here in our site in Saskatchewan, where we actually saw that in our old leaves, we were getting phosphorus deficiency. Our young leaves were still not, and that was because early on in the season, those leaves were sufficient in phosphorus. In the previous tissue, they were sufficient. The reason why they weren't sufficient here is that plant overall was phosphorus deficient, so it remobilized the phosphorus. And as a result, your lower leaves are going to senesce quicker. It's going to have impact in filling on the crop. So the other things that we're starting to look at on some of these diagnostic tools is some of the things that are coming along. This is some work we're doing with Copenhagen University. They've developed, and we've prototyped them, an in-field, real-time, handheld phosphorus and manganese tester. You basically have to put a leaf on a paper clip, and you put it in this machine. It takes about 3 seconds for it to read it, sends that data across over to a central database where it does a whole bunch of algorithms, and it comes back, and it actually tells you if those leaves are deficient, sufficient, or marginal in regards to phosphorus or manganese. Real time. Really, really quite interesting. So you can't see these colors here, but basically you get a report that's either red, yellow, or green. This is some work we did this year to help ground truth this work with Copenhagen University. We were doing real tissue tests. We were then also doing the handheld measures, and we saw a very strong correlation. And this is just one of our sites showing, you can't see the colors unfortunately here, but basically the tester, these are all the numbers that all get put into some algorithm, and then we work with A&L Labs, and what we saw is that when we were seeing deficiencies from the in-field test in real time, A&L was actually showing that we were deficient as well through traditional tissue sampling. Did this for manganese and for phosphorus. This is the next one that we're working on. This one's not quite ready, but this one measures every element in real time in the field. Every element in real time in the field. And so this is this XRP nutrient tester that really measures it out. This is all the elements it tests in real time. It takes about 45 seconds. So these are just some tools that are here today, that are coming here very soon to think about if we're driving plant production, we need to think about driving plant nutrition as an important part, and in getting a litmus test of where we actually are in regards to that. So that's really where we want to get to. Flowering is critical as well. Flowering is one of our biggest yield losses that happen in the growing season. And some of the reasons why we have such big yield loss is a lot of nutrients are not very mobile, such as boron, such as copper, zinc, manganese, sulfur. These nutrients are not very mobile, which means they don't get to the growing points of the plant very quickly. But also, we need to have a high level of concentration of those nutrients in the plant. This is a synopsis that Dr. Chakmak helped me pull together, showing that not only are nutrients not very mobile in the young part of the plant, we need them there at a higher concentration. So we'll just pick zinc, for example. Tissue sample, zinc will be a range that you need, but roughly need about 25 parts per million zinc in your leaf. But for proper pollination and proper pollen viability, you need 75 parts per million. We actually need 3 times more of that nutrient in the reproductive part of the plant, but that nutrient isn't very mobile in the plant. So now we have some of this yield loss that's happening during this flowering time. So we can't see these photos, so we're not going to go through them, unfortunately. But yeah, it's really too bad we can't see those. So this is just some of the work that we're doing in regards to, we could have picked copper. In fact, Dr. Karamanis has done copper work showing the value of a soil-applied copper in combination with a foliar copper. Did some great work back in 2003. It helped set the recommendations for the Manitoba Soil Fertility Guide, basically showing a stacked approach of copper helps drive yield. Here, because we knew we had a boron-responsive site, we did boron applications at different times, and we actually saw a difference and a value of stacking it, a soil application versus a soil plus herbicide, or soil plus fungicide, herbicide-only application, fungicide together. And we can see the value of stacking these nutrients, feeding them along the way to actually drive that crop. And in the value that it brings to the crop later on. So we won't worry about that for now. So I got 4 minutes left, so I just want to kind of quickly highlight. I'm just looking at my thing, it says 39 minutes, so I'm going to come back to this site. And again, unfortunately, this is all based off some P work that we did in 2016, where we actually did the different checks. This was an interesting trial that we did. I know you guys don't grow peas here. If anybody's from the west part of the province, in the southeastern Saskatchewan, maybe you do. What we saw in 2016, a good, strong grower fertility program gave us 67 bushels of peas, which in that part of the world, west of Saskatoon, is about 30 bushels more than the average. So our average, our baseline, our soil quality is excellent, and we don't have time to go through it. By tissue sampling and supplementing where we thought the challenges were, it brought an extra 12 bushels. But if we go to the far right, and we actually showed that with proper soil fertility, putting on the proper nutrition on in the soil, it actually gave us a 16 bushel bump. 84 bushels for good, strong soil fertility. Then combine that with the tissue sampling that we kind of jumped into, it gave us another 10 bushel bump. So we got 93 bushels of peas in an area that grows about 35. And so we built off this, and we said, there's some ROI work that you can't see the numbers on the left, so we can't go through all that. Let's build off that in 2017 and do the same thing with canola. The same plot design that you've just seen before. We looked at the pounds of nutrients that are required. We also did all the soil testing through A&L, showing what is the status of our soil at that time. What do we need to target? We can see that we have boron challenges, we have nitrogen challenges. Overall, our soil actually looks pretty good. Now, there's two things to do. When your soil looks good, you can either say, I don't need to fertilize, or you can say, because my soil looks good, can I really push it? Can I really push it? And you'll see that we did a couple different fertilizer programs that we can see how strong this program was. So we had a couple of different trials here going on. We had, our main blend, which would be common for that area, without a soil sample, would maybe be an 80-20-10-10, 1 inch away from the seed, based off the fact that we were targeting 100 bushel canola, which is incredibly bold, to say the least, based off the soil sample, working even with, Greg even gave us some suggestions. We put on a sideband, a starter, as well as some top dressing as well, to give us a pretty strong blend of product between NP, K, and S, 225 pounds of N, 75 P, and again, very, very strong program because we were pushing the crop. We're not saying that people should be doing this all the time, but we're pushing the crop to see what we can get here. And unfortunately, you won't be able to see these images as well. We can see right away, just by doing some good early season stuff, how that high fertility gets going in terms of proper placement, the seed nutrition component, some of the rooting effects that we have. These are just images showing it. That crop is moving along. That the root system is getting bigger. The above ground is getting bigger. And now all of a sudden, we're starting to see it's acquiring more water, more nutrients out of the soil. Our biomass above ground is advancing. And now we have the 4 treatments. The 2 on the left are a grower standard fertility program. On the right are based off a high yield soil program. And now we started putting on extra applications in the season based off some tissue sampling. We have the same 4 treatments laid out the same way as we've been trying to quickly go through here. Did some tissue sampling. And unfortunately, in these, whether it be the low fertility, high fertility, we're still struggling with our boron levels, even with everything we've done, which is still kind of frustrating, but that's what we have to continue to learn. We also saw that some of our other elements were not looking as great as we would like as well in regards to some of our phosphorus, our potassium, and our boron as well. So we put on a lot of fertility, but again, our tissues were still showing some challenges there. So again, how can we try to stop the drain on this crop? And again, we also did the young leaves and the old leaves, starting to see some of the challenges that are happening in this crop as it advances, just at that bolting stage. And again, maybe later on, these tissue samples, we're starting to try to fix some of these boron challenges that are happening. So then what happens at the end, we did a whole bunch of in-season applications based off tissue sampling that went on there at the different stages in the plant's life cycle. And we didn't do that, so we won't worry about the plant height. And at the end, there wasn't a lot of rain last year. You all know that. Saskatchewan had less rain. But our good fertility program, our average fertility program, was still 60 bushels. With in-season application, another 10. With proper nutrition, we got 18 bushels more and another 13 bushels on top of it when we were feeding it through at 91 bushels. So at the end, I think the thing that comes down to is your mindset. What's your mindset to do a trial on your farm? Ask the whys, ask the hows. Why am I doing this? How should I be doing this? Should I even be targeting it? Do some of the things and more than what I've talked about here today. Work with like-minded people. Don't do a trial to discredit something. I don't think any of us have time for that. I think if your job is to discredit something, well, then I'm not exactly sure what your business plan is, but your business plan should be to lower your production costs. And the only way to do that is to not do the status quo, to understand all the variables that we have involved in us. Think differently. All nutrients are essential. Target the ones that are not. And so that's about it. If anybody needs any of these nutrient wheels or things, we can actually come to our booth later, or we're around throughout the day. But appreciate your time.
Thanks for tuning in to the Manitoba Ag Days podcast. We'll see you next year from January 22nd to 24th, 2019.